Today, we'll cook a solution for Oracle migration analysis that is built using the core MariaDB ingredients with real-world Oracle patterns and MariaDB compatibility. The main ingredients for the recipe is MariaDB Cloud with vector search, available by default in the database, and this hosts the migration patterns. This is coupled with the MCP bridge, where I use OpenAI as the embedding provider. Additionally, MariaDB Enterprise Manager is used as an integrated development environment for SQL development and to monitor and validate the database tier. Here is a simple functional architecture. The LLM is not allowed to invent answers. Every decision is grounded in MariaDB's vector search, which contains curated version-specific migration patterns that are maintained by us. The result is a version-aware analysis delivered inside of the customer's trusted boundaries. The first component is MariaDB Cloud. I purchased a free tier cloud instance on AWS. This database instance will host the table containing migration patterns and is enabled for vector search. The next component is MariaDB Enterprise Manager. I have it installed and configured to connect to the MariaDB Cloud instance. I use this instance for database tasks and SQL validations. The migration pattern table resides in a database called Migration Assistant. The table has columns for Oracle snippets, MariaDB equivalent, version, and most importantly, a vector type column called embedding. As you see here, I have populated it with a few of the migration patterns seen commonly. We can populate the embeddings using a function called vec from text function as an SQL statement. I do that later through a script. So adding new patterns and updating existing ones is as simple as an insert or an update SQL statement. Let's now take a look at the setup of vector search and MCP. We will now switch to a traditional on-premise system. I have a traditional VM running Rocky Linux with connectivity established to my cloud instances. I've set up the necessary tooling to configure MCP server, to use the API key, Open API key, and to define the embedding models. I use the function vec from text. This converts the readable patterns into a high dimensional vector that represents the meaning of that code. I now have to create the vector embeddings for the patterns that we have for migrations. So let's go ahead and do that. So it's going to connect to the database and create embeddings for that. I'll go ahead and select the pattern retrieves. I see that it has created an embedding for this particular package. I have now successfully created all of the vector embeddings. This program is used to provide an UI experience to see the results. I've used Streamlit, which is an open source Python framework that helps create an interactive web application for machine learning and data science applications. In the program, I've defined an embedding model, the API keys that I need to use, and also defined the MariaDB server.py scripts location for use by MCP. Additionally, I have defined the MariaDB cloud connectivity information through a set of environment variables defined in the .env file. I will now execute the program. I now go back to the browser. I use the localhost:8501, the URL that was provided by the Streamlit program. It brings up the UI over here. Paste the code over here, okay, and do a search of the migration patterns. Okay, so let's just open it. So we see that there is a partition by range on the Oracle source. The MariaDB equivalent is partitioned by range because expressions are not allowed in partition keys in MariaDB, right? So this is information that we have noted in the migration patterns table. Let's look at the next one. It catches the send mail external service that's not available in MariaDB currently. Therefore, the minimum MariaDB version is not applicable over here. The risk is high because we don't have a direct equivalent for it in the database. So that is one way that we could go ahead and do an analysis, right? This is a cut and paste of the code that we have here. We could use the traditional MariaDB agents to inspect the schema that's there. So let's just take a look at this quickly. It's connecting through the MCP layer and it's just taking a look at the metadata of the database itself, right? What I've also done is on my local server, which is considered to be an on-prem server, I've created a local directory and created a small set of scripts that are available here. So this is a folder that the Python script is looking at. So yeah, if I just look at the three files that are there, next DDL, it's called inventory DDL. And then the third file is called the telco DDL.sql. Okay. So I'm going to go back and analyze all three files at the same time, right? So what it's going to do is it's going to scan the local directory, get the files, pass that information over the MCP server to the MariaDB Cloud instance, do a vector search on it, and provide us with the results. So as you can see, it has returned the results. So if I open the PLSQL, it sees that sendmail, another function that is looking for is list ag. List ag needs to be replaced by a group concat on the MariaDB side, and it's listing that one. Similarly, FINDDL, it sees that there is a DBMS output line, right? It's been available since MariaDB version 11.3, 11.8. Similarly, if we go into the inventory DDL, we see that there's a partition by range. It's reporting back on the change in the partition column. And it also finds Pragma autonomous transactions in here. That's all I had to offer. This program can be enhanced to do reporting, conversion, and much more.